Okay, surface area to volume ratio, also abbreviated as SA colon V, right? That would be the surface area to volume ratio. Okay, why are we talking about this? Like, why are we even bothering to talk about this strange ratio? The reason is because this is what limits a cell's size. So you might be wondering, why aren't cells bigger? Like, why not have a cell the size of a grape? Well, if you had a cell that was the size of a grape, the surface area to volume ratio would be way too small, and the cell would overheat. It would accumulate toxins. It wouldn't be able to get enough nutrients, and it would die. So let's just kind of look at a general picture here of a cell. So in order for this cell to stay alive, it needs to do the following things. It needs to be able to get rid of toxins, right? Because toxins accumulate inside the cell. You got to be able to get them out. What else do we need to be able to get out? CO2. If CO2 builds up to too high of a concentration, it'll kill the cell. We also need to be able to get rid of heat. Otherwise, the cell will cook itself, literally. By the way, where does the heat come from? There are a whole number of exothermic reactions that take place inside the cell that produce this heat. And so the cell needs to be able to dissipate that heat. Okay, so now that's all the stuff it needs to get rid of. But what about the stuff it needs to bring in? So the cell also has to be able to bring in oxygen. Can anybody name any other things it might need to bring in? Eli? Yeah? Water? What else? Think back to freshman year biology. What do cells need? What kind of reactions do they do? How do they get their sustenance? How do cells make ATP? You guys don't know this? Oh, sugars. Yeah. So another way you could just say this is food, right? It's got to be able to bring in food. Okay, and we could name other things too. Like you could just say in general nutrients, right? Nitrogen, different elements that it needs to build its molecules. Okay, so all of this exchange takes place across the plasma membrane, right? The only way for something to go in is to cross the plasma membrane. The only way for it to get out is to cross the plasma membrane. And by the way, this is all of this exchange takes place across the plasma membrane, which is the surface, right? So this is where the surface area comes into play. Greater surface area allows for more efficient exchange with the environment, right? Of all these things we listed. Greater surface area, greater efficiency of exchange. It's pretty logical so far. All right. Also, we need to talk about the volume. So interestingly enough, larger the volume, the greater the demand for the exchange, right? So in other words, if we have a really large volume, we're going to be producing more toxins. If we have a really large volume, we're going to have a higher demand for oxygen. So larger volume is greater waste production, greater demand for nutrients. Okay, so by now you can probably see why the surface area needs to be large and the volume needs to be small. Like if we want things to be maximally efficient for the cell, we want SA to be large and we want volume to be small. So we can say that over here. You could make a really big SA and then make a little tiny volume. This represents a highly efficient cell and likely to survive, right? Likely to survive. It's not going to have any problems getting rid of waste. It's not going to have any problems absorbing nutrients from the environment. But if you compare that to a cell like this that has a really big volume and a small surface area, low efficiency of exchange, it's going to die. It's not going to be able to survive. So immediately here we can see that there's a limit. There's definitely going to be a limit to these cells in their size. Okay, so here's where the math comes into play. Imagine cells of varying size. So we got maybe really tiny, medium, and then large. If we compared the surface area to volume ratios of these three cells, small, medium, and large, it would look like this. Yeah. This one would be about equal, and then this one would be the worst. Everybody getting the picture here? So the cell that has the best surface area to volume ratio, or you could say the highest surface area to volume ratio, is the tiny cell. In fact, the smaller the cell, the higher the surface area to volume ratio. And I'm going to show you the math in just a moment. But just know this general trend that the larger the cell gets, the worse the surface area to volume ratio gets. Any questions about this so far? All right, let's look at the math. Now, I know not everyone is a big fan of math, but this is easy because it's just like a little formula. Plug in the number, solve. Okay. On the AP test, you will have a calculator and you will have these formulas. They will be on the reference sheet. So if you get a problem that says surface area to volume ratio, immediately go to the reference sheet, pull up the surface area formula, pull up the volume formula, crunch the numbers, and take the ratio. So here's what that might look like for you. You might have something like this. A cell with a radius of 1. One what? I don't know. Just 1 unit. Don't worry about it. And then it wants you to compare that to a cell with a radius of 4. And then what they're asking you to do is, the question says, calculate the surface area to volume ratio for each of these cells. So you would first need to look up the surface area formula, which is 4 pi r squared. Then you would need to look up the volume of a sphere. Right, this is the surface area of a sphere. And because we've got spherical shaped cells, this is the formula we're using. The volume of a sphere is 4/3 pi r cubed. Okay, so for each of these cells, I'm going to start with surface area calculation. So for this one, it's 4 pi 1 squared. And for this one, it would be 4 pi 4 squared. Okay, crunch those numbers. Give me a moment. I'm going to do it here. I got and feel free to do this with me if you'd like, but I got a surface area of 12.6 units for the first cell. And for this one, I got a value of, by the way, order of operations, do the squared first, obviously. So 16 times pi times 4. 201.1 units. Okay, so immediately I noticed, wow, way bigger surface area for the bigger cell. So is that the better cell? Well, remember, it's the ratio that we care about here. It's not the total surface area. It's the rate compared to its volume. How is it doing, right? So now we got to calculate the volume. Now, volume of a sphere, 4/3 pi times 1 cubed. For this one, it's 4/3 pi 4 cubed. Crunching the numbers here. 4 times 4 times 4 is 64. 64 times pi. And then times 4 divided by 3. Okay, I got... By the way, you guys should probably practice. If you got your calculator out, it might not be a bad idea to make sure that you can get the right number here. In fact, let's all do that right now. Because seriously, like, it's not worth missing a point on the test because you made a calculator error. So I recommend grabbing one of these real quick. Maybe send someone up from your group to grab them. These are the calculators that you guys will use on our test, all of our tests, and probably the AP test too. Just want to make sure you guys can do these. If you have your own calculator, you can use that. Don't use a cell phone calculator because you know that on none of your tests will you ever be able to use a cell phone anyways. So it needs to be on a real calculator. But make sure that you're getting this number. I'm getting 268.1. Verify that you can get that number doing it on your calculator. If your neighbor is struggling, help them out a little bit. Make sure they can use their calculator properly. And then for this first cell, I got 4.2. So I'm going to go ahead and box in the numbers that I care about. And then we can take the ratios next. Man, and probably the units, man, I don't even know what kind of units they would use for this. Maybe cubic microns or something. I don't know. But the units don't really matter. Yeah. Maybe cube. You know, normally I just do tiny stuff. Like 4 times 4 times 4. I honestly don't. You didn't. Yeah. Show us. Yeah, so for one to cube you press the number, press Y to X, and
Wait, do I discard this?
So 4 cubes. And then I'll take that times.
Oh. Why is yours different than mine?
If you're having calculator troubles, let me know.
No.
It can be a little tricky.
Where'd you get this? Oh, fourth year. So. Oh.
All right, so if you want to follow along with me now, I am showing you how to calculate the ratio, because it's the ratio that counts, surface area to volume ratio. So you're going to put surface area on the numerator, volume on the denominator, and you're going to get a number. Notice that the number for the first cell is much larger than the number for the second cell. And what this is illustrating is it's illustrating that the smaller the cell, mathematically you're going to have a higher surface area to volume ratio. And this is why evolution has favored smaller cells. Smaller cells tend to do better because they just have more efficient exchange of nutrients and wastes with the environment, right? Any questions? All right, let's wrap things up. We'll call it a day. I'm gonna stop